Today's lesson is on segments and their measures. So I guess perhaps a good essential question would be, how can I use coordinates and algebra to find lengths of segments? Let's get some terminology down. Rules that are accepted without proof, we call them axioms, and also postulates. You will find the rules that we do have to prove are called theorems, and we're not going to talk about theorems today, but fear not, you will get your fill of theorems. A real number that corresponds to a point on a line, we're going to call that a coordinate. You'll see some examples of that in just a moment. The distance between 2 points on a line is the absolute value of the difference between the coordinates of the points. The length of a segment is the distance between the endpoints. When 3 points lie on a line, you can say that one of them is between the other two. So if you identify, you got a line, you identify 3 points, one of those points has to be between the other two. A formula for finding the distance, I think you probably learned this some time back, but we're going to refresh your memory. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And you may have even derived that formula at some point in the past. I'll give you a hint. It has to do with the Pythagorean theorem. Maybe we'll do that later. Okay, and if we want to talk about two segments that are exactly the same length, then we can say that those two segments are also congruent. Two segments that are the same length are congruent. Segments that have this exactly the same. Segments that have the same length. I'm just going to say congruent segments. Looks to be the same as the previous one. I'm not sure what I intended to say there. All right, so here we go. We've got point A, and its coordinate is x sub 1, and we've got point B, whose coordinate is x sub 2. The points on a line can be matched 1 to 1 with real numbers. That's what we've done here. For instance, x sub 1 could be 3, and x sub 2, point B, could be 10. It's just saying that x sub 1 and x sub 2 are both real numbers. The real number that corresponds to a point is the coordinate. We said that earlier. The distance, we talked about that. The distance between points A and B, written as AB. Now this is important to note here, guys. The distance or the length of AB is written as AB without the little line segment mark over the top. So let me come over here and tell you this. If I wanted to use symbols to designate the length of segment AB, then I would write it just like this. AB without the symbol on top means the length of AB, and it is the absolute value of the difference between the coordinates of A and B. That's what we have right here. Why do we need the absolute value? Because sometimes, for instance, if we wanted the length of BA, then we might get a negative number when we subtract, but we know that distance can never be negative, so we would have to take the absolute value to get a positive number. AB is also called the length of segment AB. Please remember this. If you want to denote the length of segment AB, you do not put the segment bar on top of the AB. All right, let's measure the length of a segment to the nearest tenth of a centimeter. The length of segment AB is about, and how do we do that? Well, we take the x sub 2. So here's our second coordinate. Here's our first coordinate. So we got to take the absolute value of x sub 2. So that's about 4.5. And x sub 1 is 1. So we got to take the absolute value of that. So 4.5 minus 1 is the absolute value of 3.5. And the absolute value of 3.5 is 3.5, and that is a centimeter ruler, so do not forget to put your centimeters there. So how we would write this is that AB in this example is 3.5 centimeters. Okay, if we have this line here, we see that B is between A and C, then we can say that the length of AB plus the length of BC equals the length of AC. That's how we would read that statement. The length of AB plus the length of BC equals the length of AC. So if that is true, then I can say that B is between A and C. Let's do an example here. This is a little bit hard to see, but what this first statement says is that segment MN is congruent to segment NO. So I'm going to put a little mark here. So MN is congruent to NO. We'll use one mark for that. This says that OP is congruent to PQ segment. So OP, I'll put 2 marks for those. OP and PQ are congruent. Always mark your drawings. And this tells me that this should not have a line up here. I hope that's NO and not NQ. NO equals 6. That's actually an error right there. That little line should not be there. The length of NO equals 6. So I'm going to go ahead and put that here. This is 6, which means that's 6. All right, the coordinate of M is -6. So if this is -6 right here, and the coordinate of P is 7, find all these lengths. All right, well, how long is MN going to be? MN, let's see. Well, MN is 6, right? Because it's congruent to NO, which is 6. So the length of MN is 6. OP, let's see. I think what I need to do here is write down the coordinates of my other points. So let's do that. If M is -6, I'm going to do this in green, then if the length of MN is 6, then I'm going to add 6 to -6. So that means N's coordinate is going to be 0. And then the length of NO is 6, so O's coordinate is going to be 6. And then the length of OP, where do I, sorry, the coordinate of P is 7. I have that already. So that means the length of OP is what, guys? The length of OP is the absolute value of 7 minus 6. So the length of OP is 1, and therefore the length of PQ is 1. How do I know that? Because OP and PQ are congruent. That's given to me there. So now I think I can answer all these questions. OP, now that I have the coordinates, okay, let's put Q here. That would be 8. So the length of OP is going to be the absolute value of 7 minus 6. Oh, we already did that. Absolute value of 1 equals 1. Okay, the length of MO, so O's coordinate is 6. M's coordinate is -6. So 6 minus -6, and that is the absolute value of 12. So MO is 12. MP. MP is the absolute value of 7 minus negative 6, because that is the coordinate of M. So that's the absolute value of 13, which is 13. And the coordinate of O is 6. We had that there already. All right, hopefully, this is hard to see, so hopefully I haven't mislabeled any of my letters there and made an error. If you think so, then please let's talk about it in class. All right, here's one more example. This is actually the last one of the lesson, so what I want you to do is just like before, pause here, work this problem, and then come back and I will have the answer for you to check. Go. All right, so once again, we've written the distance formula, and we're going to use that distance formula to find the lengths of all these sides of this triangle ABC. So to find the length of AB, I take x sub 2, which is 3, subtract x sub 1, which is negative 2, so 3 minus negative 2 squared, and that's going to give me 5 squared, and then the y sub 2 is 1, the y sub 1 is 4, so 1 minus 4 squared gives me negative 3 squared, which gives me 9 squared. So when I simplify this, I get the square root of 34, and I cannot simplify that. I must simplify all radicals that can be simplified. This one cannot because there's no perfect square factors in 34. And I'm going to use that same procedure, the same distance formula to find the length of AC. And when I do that, I get the square root of 68. There is a perfect square in 68. The largest perfect square is 4. So this is actually 4 times 17. And when I simplify that, I get 2 times the square root of 17. And when I solve for BC, find the length, once again, I get the square root of 25 plus 9, which is the square root of 34. It's time for you to write your summary. I'm going to let you do it on your own this time. One thing I would definitely include in there would be the distance formula and a couple of other bullets on things you learned in this lesson.